Hello friend, welcome back to my channel. Today we are going to learn about a mechanism of action of local anesthesia in normal as well as in infected or inflamed condition. Before we jump into the topic, let's discuss about dissociation of the local anesthesia first, because this is the basic thing so that it will make easy to learn about mechanism of action of local anesthesia. As you know that for clinical use, local anesthetic are available as acid salt, usually hydrochloride, and the local anesthetic salt, both water soluble and stable, is dissolved in sterile water or saline. And this solution consists of uncharged molecules, Rn, also called as base, and a positively charged molecule, RNH plus, also called cation. So that the equation consists of RNH plus is equals to Rn plus H plus. So that the relative proportion of each ionic form in the solution varies with the pH of the solution. In low pH, the high concentration of the hydrogen ion, the equilibrium is shift toward the left, that is in cationic form, and vice versa to the high pH, that in low concentration of the hydrogen ion, the equilibrium is shift toward the free base form. And the relative proportion of the ionic form also depend on the value of pKa, or also called a dissociation constant. And pK is the measure of the affinity of the molecule for the hydrogen ion. Now we are going to discuss about mechanism of action of local anesthetic molecule in normal tissue. Two factors is involved in the action of the local anesthesia, and they are: one is diffusion of the drug through the nerve sheath, and another is binding of the binding at the receptor site in the ion channel. And the uncharged lipid soluble free base form Rn is responsible for diffusion through the nerve sheath, while the positively charged form RNH plus is responsible for binding at the receptor site. And we know that Rn is free base form, and RNH is cationic form. Now let's take an example of etidocaine with pKa value is 7.9 and base portion is 25. I took this table from the Malamed of 6th edition. In this case, the pKa value is 7.9 and pH is 7.4 because it's the condition of normal condition, and base portion is 25%. This is the extracellular area, this is the nerve sheath, and this is the intracellular area. In pH of 7.4, for example, if we inject the 1000 molecule of local anesthetic with a pKa value of 7.9, then it will convert into 75% in cationic form and only the 25% in free base form. That is 75% of 1000 is 750 in cationic form, and 25% of 1000 in base form, free base form, that is 250. And as we know that the free base form is responsible for diffusion of the drug through the nerve sheath, so that the only 250 molecules goes inside the nerve sheath, passes through the nerve sheath and goes in the intracellular area. And also in intracellular area, the free base form is, if the free base form is 250, then the 25% is remain as the free base form, and the 75% is changed into the cationic form. That means the 25% of the 250 is 70 is present as previous form, and the 75%, that means 180, is changed into the cationic form, and the 180 that cationic form is bind to the ion channel. And by this way the cycle gets repeats. That means 750, from 750 also 75% is remain as the cationic form, and 25% of 750 change into the free base form, and it diffused to the nerve sheath. So this way the local anesthetic molecules work in a normal healthy tissue. Now for the same condition we are going to discuss in infected or inflamed case. In inflamed or infected case, the pH of extracellular area is going to decrease, that is pH is 6, and intracellular area, in intracellular area the pH is normal, that is 7.4. so that only the 10% of the molecule is going to form a free base form in pKa value of 7. So in 1000 molecule of local anesthetic, the pKa value of 7.9, only the 10% is going to form a free base form, while the 90% is going to form in a cationic form. And in this way only the 10% is going to diffuse through the nerve sheath, and the only 10% reach to the intracellular area. In intracellular area the pH is normal, that is 7.4, so that 25% is remain as a free base form, and 75% is going to change in cationic form. 7.5 is the 75% of 10, which means only the 7.5 is going to bind with the ion. Very low molecule is going to bind to the ion channel in infected or inflamed case compared to the normal tissue. So this way there is still pain persist after the injection of local anesthesia in infected or inflamed case. Thank you for watching guys. Hope it will be helpful for you all, and please don't forget to like, share and subscribe. I will come with next topic in next video. See you there. Bye.